CACI ramping up production of optical terminals for low Earth orbit satellites. Communication while being in space can be a hassle, unless you have the right technology at your disposal to help you. The link between our Earth and space is only using several probes and satellites that are hanging out in space. There will soon be an increment in that number by a decent amount. This is because the Computers and Information Technology Company, CACI, will bring out the production of optical terminals for Earth orbit satellites. Before we get into CACI's plan and how they plan to make all of this possible, the major reason CACI went into this entire venture is to manufacture low-cost optical terminals that will benefit the military and other commercial markets. We shall be looking at what an optical terminal is and how this technology can be integrated into an orbiting satellite of the Earth. Optical terminals and how they work. Optical communication technology is a technology that makes use of light propagation in the free space around us to transmit data for telecommunications of different kinds of networking. All of this happens wirelessly, of course. The term free space here means outer space or vacuum. The significant reason why optical terminals are being opted for in this project is that they are used in places where physical connections are impractical due to higher cost and other limitations. Optical terminals are more advantageous over radio waves because they have increased bandwidth, allowing for more excellent data transfer in less time. In outer space, the communication range of optical communication manages to cover over several thousand kilometers. There is a massive potential to bridge distances between other planets using these terminals using beam expanders. Creating intersatellite links using optical terminals is what NASA has adopted in the last decade. Even now, work is being done in this field to make communication from space and back even more streamlined and effective as possible. The most prominent companies in the world, such as SpaceX, Facebook, and Google, are working on concepts on how to deliver the most promising means of data transfer and optical terminals that will be applied to satellites to change the game for these companies. Of course, this technology will only be as effective as the machine it will be integrated into. This is why these optical terminals will be made for low Earth orbit satellites. These satellites are, as its name suggests, but let us look into the working of this kind of satellite, shall we? It might not be as simple as you might expect. But after you know how these satellites work, you'll know even better how these optical terminals will be successful and how well thought out this move from CACI is. Low Earth orbit satellites. Low Earth orbit or LEO satellites have a circular orbit present at the height of 250 to 2,000 kilometers from the surface of the Earth, and depending on the altitude, their range varies between 90 and 120 minutes. They have high velocity and have low altitude, making 12 to 16 Earth turns per Earth day. Since their altitude is relatively low, this makes their velocity high. An LEO or LEO satellite manages to experience 12 to 16 sunlight and night periods in a single day, with much faster rotation. It requires a rapid medium through which it can transmit information over a significant distance in a short amount of time. Speaking of time, the maximum time a satellite is present above a local horizon for an observer on Earth is up to 20 minutes. This is the time used to transfer information such as data, photographs, and images to ground stations positioned in strategic and well-planned locations. Satellites in LEO are well affected by an atmospheric drag that gradually makes the orbit deteriorate, along with the typical lifetime of an LEO satellite of 7 to 10 years. Most of the LEO satellites are used for observation of the Earth. The most famous example of an LEO satellite is the Hubble telescope, which was launched into Earth orbit in 1990, and it's still active. Currently, it is working in compliance with the James Webb Space Telescope, which was launched only last month, but soon it will succeed the Hubble telescope. Another advantage of LEO satellites is that shortly they might have even exceeded the faster ground-based networks if they are applied for our use on the Earth. To put this into context, OneWeb, a London-based company, began launching LEO satellites the size of washing machines in July 2019 on its transmissions between space and South Korea at an average latency of 32 milliseconds. At the same time, Elon Musk has said that his Starlink system aims to have a latency of 20 milliseconds at the start, and he hopes it will cut the number soon in half. Latency is simply the rate at which information is transmitted and returned. This is why financial firms have put their hand in this venture, because this technology of LEO satellites could prove to be the future for us. Now that we've told you the numbers these satellites deliver, listen up about the orbit systems that roam the Earth at a higher altitude. These high orbit systems have a latency of about 600 milliseconds for a single round trip. Although this number might be okay for broadcasting information, two-way communication is a severe drawback. Now that we've talked about optical terminals and low Earth orbit satellites, we can now understand the entire scenario of CACI better and in more detail. How this acquisition will benefit the parties involved and what it means for the future of space. The CACI scenario. The acquisition of SA Photonics in December by CACI was a great move because the CACI decided to pursue the Navy and business markets for optical terminals that are going to come at a lower price and be more compact. In the coming months, CACI will ship 40 optical communication terminals for the Projection Superior Analysis Initiatives Company's Blackjack satellites. These terminals will be produced below a Defense Advanced Research Project Agency or DARPA contract valued at $16.3 million, which was awarded to SA Photonics in 2020. SA Photonics was acquired by CACI last year. The optical terminals which will be used to attract satellites in orbit to allow them to switch information in-house. CACI already makes laser communication technology for NASA, and it purchased SA Photonics to carry forward Navy and business markets for optical terminals that are smaller and cheaper than usual. The company is increasing its manufacturing sites in Florida, so it will probably produce a decent number of optical terminals per year. The first batch of these terminals will most likely be delivered this summer with the Blackjack satellite TV for PC made by Blue Canyon Applied Sciences, and it will be able to launch this fall someday. The Blackjack experiment shows the capabilities of small satellites in low Earth orbit for Navy communications, missile warning and navigation. Optical terminals from SA Photonics are already in the house as a part of a DARPA demonstration called Mandrake 2, with two smaller satellites launched on June 30th. In accordance with SpaceX rideshare missions, the company has deployed them to show out optical inter-satellite hyperlink expertise to prepare for a primary launch of Blackjack sites. A DARPA spokesperson mentioned on January 28th that the Mandrake 2 satellites stay wholesome and testing is going on. When the successful execution of these Blackjack satellites take place, it will place the company in a position where it can compete for even larger orders for the Space Development Agency or SDA. The SDA still needs to finalize 3 prime contractors that will help build 144 satellites for the transport layer Tranche 1. Each satellite is expected to have somewhere from 3 to 5 optical terminals, which will make this a bigger opportunity than before. With Tranche 1 being put at the top of the priority list, SDA will need to decide on contractors soon. That isn't all CACI is doing. It's also working on courting commercial broadband constellation customers because the optical terminals they will provide will produce high bandwidth of data. CACI is in talks with at least 2 commercial constellations today, and there is rising optimism that a deal might be struck very soon. CACI's move of ramping up the production of optical terminals for their satellites will be a stroke of genius. When most of the companies in the world are making a difference on Earth, going out into space and making sure our communication systems become faster is even more incredible. You can't help but appreciate the fantastic foresight. We hope the plans that CACI has in the pipeline reach completion quickly, because when these satellites are released with the optical terminals, data transfer will be even faster. If this doesn't get you excited, then you're probably not that much into space exploration.